compressed air friends. You may remember a video I did a little while back on this machine where I kind of went through the diagnostic process of troubleshooting this machine when it was not unloading properly. So finally got to come back and did a refresh on all the control parts here. And I just wanted to maybe walk through this control system a little bit and maybe help shed even a little bit more light on how these work. I am absolutely certain I'm going to screw this up, but just bear with me here. So let's begin at the beginning. Over here we've got this shuttle valve with these two lines feeding. What this is, this line right here comes right off of the minimum pressure check valve and comes over here. This is line pressure. This line right here actually leads down and runs over to our line pressure sensor. And then on the other side of this shuttle valve, this line comes from the sump. And all this is really doing is just ensuring that whichever one of these sides has the higher pressure, whether it's the line pressure or the sump pressure, whichever one of these has the higher pressure is what is going to be feeding this control system here. So that's all this shuttle valve is doing, is just making sure whichever one is greater is what's feeding this system. Then we come through our pressure regulator here. I think the book says anywhere between like 25 and 30 or something like that, but experience has taught me between 20 and 25. Ideally about 22 is where I like to set those. And then we come through our check valve here, and we come right into our inlet valve closed solenoid. This is a normally open solenoid valve that energizes on load. And then we have our normal, or our inlet valve open solenoid, which is a normally closed solenoid that will open on load. Then we have our blowdown valve, which is a normally open solenoid that will de-energize on blowdown. So what we got going on here, we got air pressure comes in, and kind of our first stopping point is right here at the inlet valve closed solenoid. So obviously, if we want this thing to run at full load, we're going to close the solenoid, which this whole entire control system is now void of air. And our inlet valve open solenoid will energize and allow air to flow freely through this system in order to vent all the way to here, which is where our open signal will come. So this is basically a venting solenoid right here, is all this really is. Now when we want this machine to unload, not blow down, unload. Remember, these Garner Denvers, you have the unloaded phase, and you have the blowdown phase. We'll get to that in just a moment. I covered that a little bit before. So if you want this machine to unload, what we're going to do is we're going to keep the blowdown valve closed, so that's going to stay energized. We are going to energize these solenoids, and what's going to happen now is the vent here is going to close. So this line here has no flow right here. So our air is going to come through our inlet valve closed solenoid. It's going to come up. It's going to come around down to right down here. Now we have a check valve that is opposing flow. It's not, I should say, yeah. Our check valve is biased this way, so it's not going to allow that to run back in here. But what it is going to do is all that air pressure is going to run out this line right here, which comes down, connects right here at the inlet valve. So when we put pressure here, we're going to swell this diaphragm and push that inlet valve closed. At the same time, that same air signal is going to travel up this line to our control valve here. Now what this control valve does is extremely important, because when you close an inlet valve, you are restricting the machine's ability to pull air in now. reason why that's a problem is if we discharge the sump to 0 psi, to basically atmospheric pressure, the oil doesn't circulate. So anytime we unload a rotary screw air compressor like this, we've got to have a way to keep a little bit of pressure in the system to keep oil flowing when it's unloaded. Otherwise, when the machine unloads, it might run cool for a minute or two until all the internal pressure bleeds off, and then it's going to start overheating because you're going to start starving the air in for oil. So what this guy does is when we give the signal down here to the inlet valve to close, that same signal travels up here and commands this valve to open. Okay, there's a diaphragm in here, it just pushes it down, opens it up. This line right here, if we follow it, which it runs into a massive crap over here, it gets confusing, but if we follow this line back, this is connected to our sump, and then the line out of the other side of that valve comes right here, down and around and into here. So what that does is that basically allows the sump pressure to evacuate in here below the inlet valve, right? The inlet valve's closed up here. So we're evacuating pressure in here below the inlet valve, and that allows that pressure to just kind of recycle, and it keeps the oil flowing through the system. Obviously, we're not worried about it being unfiltered because it's coming right from the sump. Anything that's already in the machine already went through the air filter and is filtered. So that is how we keep unloaded sump pressure in this machine. Now, when we want to load again, this is going to close, this is going to open, and it's going to allow all of our control lines and everything to vent. And once that pressure is removed from the inlet valve, holding it closed, it will open back up. We're all good. Now, once we run unloaded for a certain amount of time on these Garner Denvers, usually 5 to 10 minutes, if the machine has not been called to reload, then we're going to enter what's called the blowdown phase. So we're going to pretend we're running unloaded again, right? This is closed, this is open, pressure's flowing through here, inlet valve's closed, control valve's open, sump pressure's basically just recycling at this point. So then what happens is our unload timer has expired, and now we're going to go into blowdown. And all that's going to happen is this valve is now going to open. This line right here runs directly to the sump, and once this line opens, or once this solenoid opens, and this pressure is allowed to come through here, well, now the entire control system is vented, and we're going to blow our sump down and all that, and that little guy right there is going to ensure that we keep unloading sump pressure on the machine while it's just unloading. So, even with all that, I still look at this control system and my brain hurts a little bit. Like I said, I can troubleshoot them and I can fix them. I'm just not super proficient with them. You know, these things are kind of on their way out the door anyway, but there's still plenty of them out there because these are freaking solid machines. So, my go-to, if I have one of these machines that's making me scratch my head and I need a little outside perspective or something, my go-to on these machines is John Davidson. So if you are not connected with John Davidson at this point and you work on Garner Denvers like this, you should probably shoot him a connection request because he lived and breathed these machines for many, many years, and I can usually just shoot him a text message and say, hey, it's doing this, I've checked X, Y, and Z, what do you think? And he'll be like, oh, what did you check this? And say, well, shit, okay. So anyway, again, in the other video I had some drawings of the system and how it all works and what has pressure when it's blown down and what doesn't. I'll link to that down below in the comments, and if you want to get your hands on those drawings, just let me know, I'll send them to you. I believe they're in the books as well, but sometimes it's easier just to have them emailed to you, so let me know if you want those. But anyway, that's what I got, friends. Have a good one. See ya.